Okay, welcome to Chapter 6, Trigonometry. I am so excited to bring you this next chapter in our odyssey of math learning. Um, okay, well, in grade 11, you guys actually learned the exact values of sine, cosine, and tangent for these particular angles. So you guys are probably drawing pictures that look sort of like this. You had a unit circle. This was 0 degrees here. This was 90. This one here, see that? That was 180 degrees. This one here, 270. And then you've literally come full circle, and this would be 360. Alright, so this whole unit, we're going to explore this again, but we're going to be doing it in a unit of measurement called radians. Radians, we'll be talking about the unit circle again. We'll be drawing sine and cosine graphs, and just for fun, we'll look at tangent graphs as well. We'll be doing a lot of triangle stuff. Next slide. Okay, let's talk about positive and negative angles. So if an angle starts here on the positive x-axis and rotates in a counterclockwise fashion, then we call that a positive angle. Usually there's a terminal arm here, so that's where the angle stops, and we say that this angle, so let's just say that this one here is 135 degrees, we say that this is an angle in standard position. Sometimes in the future, a lot, we're going to be talking about the reference angle, which is always between the terminal arm and the nearest x-axis. So there's usually a lot of confusion. Standard position is starting from here going to the terminal arm. The reference angle is from the terminal arm to the nearest x-axis. So this is a positive angle. Can draw another positive angle right here. So let's start here, and if I go all the way around, well, hey, we made a full rotation. That's a positive 360 degrees. It says notice angles can be greater than 360. So if I start here and I rotate around, boom, here I am at 360 degrees, and let's say I keep going, well, that's an angle that's greater than 360 degrees. So just because I'm landing in quadrant 2, let's just say this is 360 plus, oh, I don't know, another 150. So that might be, now I lost track of what I said, 460, that would be 510 degrees. And I'm just completely making this up. So I did 360 degrees here, and then I went 90 degrees, then a little bit more, 510. Angles can also be negative. So negative just means that we're traveling in the opposite direction. So a positive angle starts here, moves counterclockwise. A negative angle is defined as moving clockwise. So for example, this is the angle negative 90 degrees. If I was to draw another one, I could say draw this one, and this would be negative 270 degrees. Just remember from grade 11 that each quadrant is 90 degrees. Okay, let's talk about angles. So if an angle ends up in the same position as another angle that's the same, we call that a coterminal angle. This means that the arm of the angle is in the same position. So if I was to draw an angle here, and here it is in red, so this is called the arm, and we got some angle theta here. If I then walk around my unit circle and I draw another angle that happens to be in exactly the same spot, we would call that a coterminal angle. So it appears the same, but I actually walked around all the way and ended up in the same spot. So my measurement is going to be where I started plus 180 degrees. So basically, you can keep doing this process over and over again. So I can start on the blue angle, walk around again, be in the same spot, but now I've actually walked around twice. Okay, so we can describe how many degrees you had to walk around and just say that these are all coterminal angles. So to find a coterminal angle, all we got to do is add 360 degrees. So if I got an angle of 40 degrees, If I take that and I add 360 degrees, then the angle 400 degrees is coterminal with 40. I can keep doing that, so I can add 360 again, and I'll have another coterminal angle, which is 760 degrees. So 40 degrees, 400 degrees, and 760 degrees are all coterminal. Okay, so if we walk around on the unit circle, we'll end up in the same spot every time, but we'll have traveled a different distance. We can go negative as well. So if I take my 40 degrees and I subtract 360, I'm going to get negative 320 degrees. So that angle is coterminal with 40. Let's talk about that for a second as far as a picture goes. So here's my angle of 40 degrees. Now, when we're talking about negative angles, we are actually walking, let's see, this way on the unit circle. Okay, so if I go a full 360 degrees, I've now traveled what we would say negative 320 degrees, and that would describe the same position on the circle. So again, we can subtract 360 from this, and we'll get negative 7. Oops, not 7. Silly DeMuro. We can get negative 680. So that would be coterminal with 40 degrees. Okay, continuing on. If we want a negative angle that's coterminal to 100 degrees, that's so easy. So we're just going to subtract 360 degrees, and we're going to get negative 260. A positive angle that's coterminal to negative 19 degrees. So here's negative 19. So if I was to draw a picture of that, that would mean that my terminal arm is down here. This angle here, is going to draw an arrow, that's 19 degrees. That's negative 19 degrees. Okay, so if it needs to be a positive angle that's coterminal, I'm just going to add 360 degrees. And let's see, I'm going to get 341 degrees. Okay, so that just means that, because this is positive 341, that means that if I start here and I move counterclockwise 341 degrees, I will land in the same place as doing negative 19 degrees. Fascinating. What reference angle in quadrant 1 is in the same position as 500 degrees? Let's think here. So if we're looking for a reference angle that's the same as 500, they're basically just asking us for a coterminal angle. Now if we want to be in quadrant 1, well that means that, well, this one here, this is quadrant 1. Okay, so basically I can continue subtracting 360 degrees because I know that that will give me a coterminal angle, and I keep doing that until I'm in quadrant 1. So 500 minus 360, well, what does that give me? That gives me 140 degrees. Now, that isn't quite in quadrant 1 yet. We know that this here is 180 degrees. So if I draw an angle of 140, that means that I'm starting here and I'm going all the way to this terminal arm, and that's 140 degrees there. Now, it is important to note that they are asking me for a reference angle. Okay, and the reference angle is always between the x-axis and the terminal arm. So this, that I'm highlighting in black here, this is what we would call theta r, or the reference angle. Okay, so if this is 140 degrees from the terminal arm to the x-axis, if you do the math, that'll be 40 degrees. So my reference angle is 40 degrees. Now, is this in quadrant 1? Well, yes. Any angle between 0 and 90 degrees is in quadrant 1. So reference angles by nature, these are always basically quadrant 1 angles. And we'll talk about reference angles quite a bit more, so stay tuned. Last example here says, write a statement for all angles coterminal to 30 degrees. Well, a statement for all angles, well, that means an infinite number of angles. So 30 degrees would be right here, 30 degrees. Now, we know that if we're going to find coterminal angles, well, we're just going to keep adding 360 degrees to 30. So if I'm going to write a statement, I'm going to write 30 degrees plus 360, and let's just say times some number k. So if I want to go once around, k would be 1. If I want to go 2 times around, k would be 2. I need to write all angles that are coterminal, so that means that I could subtract 360. Well, if k was negative, then that would be the same as subtracting 360. For instance, if k was negative 1, then we would get 30 subtract 360. So as long as I say, hey, k is an element of the integers, then I have written my statement for every angle that's coterminal to 30 degrees. Neat. Okay, so first question about coterminal angles. So it says determine the measures of all the angles in standard position between negative 1000 degrees and 1000 degrees that are coterminal with 150 in standard position. Sketch the angles. Great. I love pictures. So here I am sketching my angle of 150 degrees. So this is 0, this is 90, this is 180. So for a sketch, you just have to be in the right quadrant. So I'm just going to draw a terminal arm here. And I'm going to draw an arrow, and I'm going to draw 150 degrees. Beautiful. So many art schools are contacting me right now. So if we're going to do all the angles that are coterminal with this, we know that we're going to be adding and subtracting 150 degrees. So I'm going to start with 150. Okay, now if I add 360 degrees to that, I'm going to get 510 degrees. I'm going to check. Still less than 1000? Perfect. Let's add 360 again. I get 870 degrees. Now, if I add 360 again, I know I'm going to be over 1000, so I'm going to stop there. That's my last angle. Now I'm going to go backwards. So now I'm going to subtract 360 degrees from 150. That's going to give me 210 degrees. Negative 210. I'm still not at negative 1000, so I'm going to do it again. I'm going to get negative 570 degrees. And I think I can do it one more time. Just going to think here for a second. Yeah, so if I subtract negative 360, I'm going to get negative 930 degrees. Now if I do it again, I'm going to go past what they're asking, so I'm done. So this would be every coterminal angle to 150 degrees within the range they asked. Now, in part B, oh, well, one more second in part A. They say sketch all the angles. Let's not sketch all of them, but let's think here for a second. Yeah, let's do, say, 510 degrees. So if I was to sketch that, that just means that, hey, I'm starting here, I'm adding another 360 degrees to get back here, and 150 plus 360 is 510 degrees. So, isn't that dandy? If I was to sketch, just for fun, say an angle of negative 210 degrees, that means that I'm going backwards. So I'm starting here, I'm moving clockwise, and I'm going to end up in quadrant 2, right? It's exactly the same as 150. Okay, the only difference is that to get there, we traveled negative 210 degrees. So that would be the sketch in standard position of 150, which if we start here and go this way, we get exactly to the same place, but we traveled 150 degrees counterclockwise. So for part B, they want us to write, you know, all the expressions for a coterminal angle with 150. So we've seen that before. We're going to take 150. We're going to add 360 times k, and as long as k is an element of the integers, then we're going to be getting our negatives and our positives, so we are all good to go. Happy face. Alright, let's look at trig ratios on the unit circle. Man, these typos are bad. Okay, so over here to the right is probably one of my favorite pictures of all time, because it shows a terminal point px on a unit circle. So when we draw this point px, we can draw a nice little triangle where in here we have the angle theta. That's always between the x-axis and the terminal arm. From the origin to that point, we call that r. And the point xy, well, this is x and this is y. right? So we can easily look at the y-axis and see the height of y, and can we look at the x-axis and see how many units x is. So you're actually familiar with the Pythagorean theorem, or I hope you are if you're in grade 12 pre-calc by now. And you can actually find the coordinates for r by doing x squared plus y squared equal r squared. So it looks a little different, but that is our Pythagorean theorem. So that also happens to be the equation of a circle that's centered on the origin and has a radius of r units. So there it is. Then in grade 11 and in grade 10, you talked about a couple trig ratios. So you guys remember that sine theta is opposite over hypotenuse. Well, in grade 12, we sort of frame this a little different, and we say, hey, sine theta is now the ratio y over r. So if we go back to our terminal point and our triangle here, using our new letters, we can see that opposite is y, and the hypotenuse is r. So yeah, sine theta is actually now y over r. Now this is nothing new, it's just a different way of thinking of exactly the same thing. Cos theta, well, that used to be adjacent over hypotenuse. But now, when we look at our unit circle here, cos theta is adjacent, which is x, and the hypotenuse is r. So it's x over r. I'm going to write it down here too. Okay, that leaves tan theta. So tan theta used to be opposite over adjacent. Okay, but yeah, you guessed it. Let's go look at our picture here. Well, opposite's y, and adjacent's x, so tan theta is now y over x. Okay, question time. So we got point 34, and it's a terminal point of an angle theta in standard position. Then it asks us to find the values of sine, cosine, and tangent. Alright, I live for this stuff. So here we go. Let's draw our nice little crosshairs. We can draw a little circle if we like. And the point 34, well, that's going to be in quadrant 1. So I'm just going to say, hey, here's the point 34. And from there, I'm going to construct my triangle. So this is going to be r. Don't know the value of that yet. Remember, x is 3, so when I draw my triangle, here's the 90 degrees. This is 3, right? That's the value of x, and y is 4. Here's my angle theta. So first step, if I'm going to find sine, cosine, and tan, is, well, I better find r. So I'm going to use my modified looking Pythagorean theorem and say, okay, that's r squared. So x is 3, so just use brackets. Well, I'm not going to, but you should. None of these numbers are negative, so it's not going to matter. So I'm going to go 3 squared plus 4 squared, and that equals r squared. Well, this is a 3, 4, 5 triangle, so I should get 9 plus 16, that equals r squared. So when I add them up, do the square root, I'm going to get 5 for r. Right? Square root of 25 is 5. So once I have that, I know that sine theta, well, again, that used to be opposite over hypotenuse. So you can still think of it that way, right? And write 4 over 5. But just remember that that is the ratio of y over r. Okay, so for cos theta, again, just trying to use my new terminology. Well, that used to be adjacent over hypotenuse. So we would say, well, that's x over r. So that's 3 over 5. And tan theta, the ratio, again, we used to say, hey, that's opposite over adjacent, but now we say that's y over x. So try to get used to that new language. So that's 4 over 3. Boom, done. All right, let's do another one. So this time we have a terminal point, but it's 1, negative 3, and it's saying it's in standard position, probably the best position in math, a standard position. So find the values of sine, cosine, tangent. Drawing a picture in this unit is going to save you a lot of hassle. So when I draw a picture, I can think, okay, x is positive, so that's either quadrant 1 or quadrant 4. Y is negative, so that has to be down here. Okay. So I'm just going to write that's 1, negative 3. Okay, then just draw your triangle. So this line will always drop down to the x-axis. That's always 90 degrees. X is 1. Y is negative 3. So that makes sense. This is theta. and this is going to be r. Okay, so first things first, find r. So you're going to go x squared plus y squared equals r squared. And we're going to get 1 squared. Now be careful, y is negative, so don't forget brackets. There we go. So basically we're going to get 1 plus 9 equals r squared. Well, oh no, this is 10. So I get 10 equal r squared. So now when I do the square root of this, really you're just better off leaving it as the square root of 10. Okay, so it's not a perfect square. You know, we're in grade 12 now. Things like this happen. So I'm just going to roll with the square root of negative 10. So now when I find sine theta, just remember, using our new formulas, that is going to be y over r. So the y value is negative 3. The r value is the square root of 10. And I'm just going to leave it like this for a second. Actually, no, that's a lie. In grade 11, you guys learned about rationalizing. So technically, we don't like leaving square roots in the denominator. The exam may or may not ask you to rationalize. You're totally okay leaving it like this unless they ask. But if you want to rationalize, you're going to multiply by a form of 1 and get rid of that square root 10. So square root 10 divided by square root 10 is 1. So when this is rationalized, it's going to look like this. So it's going to be negative 3 times the square root of 10 divided by just 10. Right? Square root of 10 times square root of 10 is 10. I think that's enough said, right? Square root of 100 is 10. I'm not going to say anything else on that matter. So generally, we're not going to do this to our answer unless we're asked to do that. So let's do cos theta. So again, cos theta is x over r. So the x value that was given, it's 1. And we found that this r was the square root of 10. And tan theta, I'm not even going to rationalize that. I don't care. They didn't ask. Tan theta is y over x. So that one is going to be negative 3 over 1. And, you know, we'll clean it up. And you get negative 3. All right. We're making really good time. And I think we're totally done. There's nothing left to do. Not sure what this is. Man dancing in trench coat. Woman, glasses, or dancing. No idea what's happening. We're no strangers to love. Ha 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 ha. Okay, sorry guys. I cannot resist. That had to be done. We are nowhere done near the notes. We have, well, we're on slide 7. There's like a million slides. So I'm going to keep going. Next thing, so this is actually going to be new material here. All of these trig ratios actually have reciprocals, and we've been basically hiding that from you since, I don't know, grade 10. It's been a blast hiding it, but now it's time to tell you what they are. So the reciprocal of sine is called cosecant. Good stuff. The reciprocal of cosine is called secant, and the reciprocal of tangent is called cotangent. And I just want to remind you that when we're doing the reciprocal of something, we are doing basically 1 over y. So when we say cosecant, so for example, cosecant is like this. That's the abbreviation for it. So reciprocal of sine, well, that would be 1 over sine theta, right? So we're just doing the reciprocal. The reciprocal of cosine is secant. Well, okay, so secant, we spell it S-E-C for short, and the reciprocal of cosine would be 1 over cosine. And yeah, you guessed it, tangent is cotangent, so if you want to take a stab at it, it's actually COT for cotangent, and that's going to be 1 over tangent. Now, if we use our new terminology and we think about, okay, well, cos theta, that's x over r. So if you go 1 over cos theta for secant, then doing the reciprocal, well, that's r over x. Okay, so if you ever have to find the ratio for secant and you have this information, then you can just say, hey, it's r over x. Similar for sine theta, so 1 over sine is cosecant, and if you do the reciprocal of y over r, you get r over y. Okay, same thing for cotangent, so well, there it is. Cotangent is x over y for the same reasons as before. So if I was to do just a small little example, and I said, hey, the value of sine theta is 0.5, what's the value of cosecant theta? Well, this would be handier if it was a fraction. So that's a half. So cosecant is 1 over sine. So if you do the reciprocal, then cosecant theta would equal 2, right? That's the reciprocal of a half. If cotangent was -3, what was the value of tangent? So just do the reciprocal of -3. Remember, it's divided by 1. Well, then tangent must have been 1 over 3 negative. Okay, we can put the negative in front, or we can leave it in the numerator. Doesn't matter. Okay, now we're going to go over basically a bunch of different question types. The first one is if I give you a point location and just ask you to determine a bunch of trig ratios. So we've seen the terminal point question. They drew us a nice little lovely picture, and they're asking us to determine the exact values of the 6 trigonometric ratios for theta. So they drew theta in standard position. We'll have our triangle like this, so we know this is -2, this is 5. We need to find r before we can find any trig ratio. So we're going to use this formula here, as usual. And I'm going to show a little less work, right? But we're plugging in 5 squared plus, don't forget to use negatives. Now, I wrote them in the wrong order for x and y. It's not going to matter. But just use brackets. So we got 25 plus 4, so we get the square root of 29 for r. And we're all done solving. So we can leave it like that, that's fine. And then I sort of pre-wrote all the trig ratios to save some time. So we know that sine is y over r, and that's going to be 5 over the square root of 29. Now, I've conveniently grouped it with its reciprocal cosecant. So remember, cosecant is just 1 over sine. So if you're going to find cosecant, just do the reciprocal of sine. So we got the square root of 29 over 5. And just a reminder that if you're using the formula, that is r over y. Okay, so either one works. Let's see the next one. So cosine, well, that's x over r. So that's -2 over the square root of 29. Okay, now secant is the reciprocal of cosine. So if I go 1 over cos and just do the reciprocal of what I have, I'm going to get the square root of 29 over -2. Again, just a reminder, that is the same thing as r over x. Whichever one floats your boat. Tangent, well, that is y over x. Now, y was 5, x is -2. So there's tangent. Cotangent is 1 over tangent. So once again, I can just do the reciprocal. Boom. Donezo. So all 6 trigonometric ratios in their glory. Okay, next time a question is where I give you one ratio and ask you to find other ratios or perhaps some angles. And this is really totes my goats where it really starts to get fun. Advice, draw a picture. Okay, so if they say cos theta is -12 over 13, just a reminder, the formula for cos theta, well, that's x over r. Okay, so that's telling me something that my x value must be negative. My r value is always going to be positive. Here they're telling me I'm in quadrant 2, so that actually helps me out a bit, because x is negative either in quadrant 2 or quadrant 3. So, but if I am in quadrant 2 here, when I draw my triangle, and it's a must, please draw it. Don't skip this step. It's so important. Your art teacher's right. Picture's worth 1,000 words here. So x is -12. Okay, r is 13. Okay, so now I got a nice dandy picture. I can go ahead and find y, because they're asking me to find the other 5 trig ratios. So I'm going to need y. So you can use this formula here. Okay, I can't believe this thing from like grade 8 comes back, but here we are. So if we're solving for y, we can plug in x is negative 12, don't forget the brackets, plus y squared equals r squared, which is 13 squared. Okay, do the math. So you get 144 plus y squared equals 169. Okay, subtract 144 from both sides. You're going to get y equals the square root of, let me think here, 5. 169 minus 144. That gives you the square root of 25. So you get y equals 5. Okay, now if we're in quadrant 2, just fact checked, and yeah, should be positive, so we're all good to go. Now we can go ahead and write all the trig ratios, so I just can't wait. Sine theta, so that's y over r. So that's going to be 5 over 13. I can go ahead and do a secant. No, that would be cosecant. Starting to get confused. Right, I just want to do the one that's related to sine. So 1 over sine is cosecant. So that is 13 over 5. Let's go ahead and do cos theta. Right, now that's x over r. So x is negative 12, and r was 5. Okay, now the way I remember, or I try to remember, usually remember, which one is related to cosecant, which one's related to cosine, that's secant, so that's 1 over sine. How do I remember? It's really stupid, but I just say, hey, you know, cos has an s in it, and it has a c in it, so secant is the one that's related to cos, and then the other one, cosecant, is the one that's for sine. So if I do the reciprocal, I'm going to get 5 over negative 12. Now, how do I remember tangent? Well, that's y over r. So let's get that out of the way. So that's 5 over 13. And what I meant to say is, how do I remember cotangent is the one that's related to tangent? Well, cotangent has the word tangent in it, so I'm going to do the reciprocal there. So those are my pro tips on how to remember all your trig ratios, because now you have 6 of them, and boy, is that confusing. Okay, last question here. So it's kind of slanted because it's so heavy that it can't even stay straight. They start with, suppose that cosecant theta equals 3. So let's focus on part A. It says determine the exact values of the other trigonometric ratios for theta between 0 and 180 degrees. So basically they're saying that we are stuck in quadrant 1 and in quadrant 2, right? This is 0 degrees, and as we move this way, this is 180 degrees. Okay, next step here is we generally don't like to think of cosecant theta. You guys are used to sine, cos, and tan, and for calculator questions, your calculator only has sine, cos, and tan buttons. Some calculators have the other ones, but anyways, so if we think of cosecant, we know, well, hey, that's related to sine. Right, so we know that sine theta, if we do the reciprocal of 3, we get 1 over 3. Okay, so that's a lot more useful for us because we know that sine theta is the same thing as y over r. So we could go and construct a triangle in quadrant 1 and in quadrant 2 because sine theta needs to be positive. And it's positive in those 2 quadrants, and we can go find all the other exact values of all the other trig ratios. So that's a long question. So let's take a look in quadrant 1, for example. So if I draw my terminal arm, draw my triangle, and say, okay, sine theta is 1/3, so here's theta, here's my 90-degree angle. So the y value is this one, right? So that's 1. And r value is always the hypotenuse here, that's 3, right? This would give me a sine ratio of 1 over 3, y over r, or opposite over hypotenuse, however you want to think of it. So I can find x, okay, and I'm going to do a little less work here, but when I find x, I do believe that I'm going to get, oh, I don't know, I better just do the work. So I'm going to use this formula. it's getting a little too late at night to do this in my head here. So y squared is actually the one I know, so x squared is the one I'm looking for. Y squared is 1 squared, r squared is 3 squared. So I'm going to get x squared equals 9 subtract 1, so it's going to be 8. So when I do the square root of it, I'm going to get that x equals square root of 8. Okay, I'm so glad that's over. Okay, now to find the other trig ratios, well now this is exactly the same as this problem here. So we have a completely solved triangle. We can find the other trig ratios. I'm going to update the screen with all those ratios and give you a second to try it out on your own. Maybe just pause the video here. Okay, there's the answers. So again, you can pause the video here at this point if you want to copy them down. Now that's only part of A. The other part of A would be doing the other side here. So this is actually something that we're going to learn more about as we complete this section of notes. But I just want to show you how to do the work in the second quadrant. It's actually not as much work. So we still know that cosecant is 3, so sine theta would be a third. So again, so that's y would be 1 and r would be 3, right? And in quadrant 2, my y values are still positive. My r is always going to be positive, so that makes sense. What's the only thing that changes in quadrant 2 as far as signs go? So that would be the x coordinate is now negative, right? So in quadrant 1, all my x values were square root of 8. But in quadrant 2, that would be negative square root 8. Okay, so how does it affect the ratios? Well, any ratio that has an x in it is now negative. Okay, so if we go through and do the ratios for quadrant 2, and I'm going to pause the screen in a second and write it all out, any ratio that has an x is negative. So just for example, tan theta, well, if we look at quadrant 1, it used to be 1 over the square root of 8. Okay, but now in quadrant 2, it's negative square root 8. So that would be the new ratio. So identical ratio, you just have to think of the sign. Cotangent, which is the reciprocal of tangent, is now negative square root 8. Okay, so I'm going to pause and throw up the other answers. So, I don't know, pause the video. Okay, check it out. So sine and cosine, right? These have not changed in quadrant 2. They're still positive. But cos theta is now negative this, and secant will now be negative that. So that should be pretty fast. Next slide. Okay, we're going to do another question here. This is a really important one. It involves some review from grade 11. And I just want to stress, I don't think I can stress this enough. We are going to do so many of these questions in the coming days that you guys are going to be puking these up. Okay, so if it seems like I'm going a little fast here, it's totally okay. We're going to do more, and you're definitely welcome to, come back and pause the video and watch it a couple times. All right, so basically what we're going to do here is... Oh no. It's, okay. I don't know why this is happening. It's video again. I don't know what it is. Oh, sorry. Oh, I could. It had to be done. It had to be done again. These notes are getting too long. Oh, I'm gonna be laughing about that for a long time. Like, someone look at Demi's face. What is she doing? She's probably not too happy right now because this is getting in the way of her math. Oh, I'm so sorry, Demi. I'm gonna be laughing about this for a long time. Okay, all right. It had to be done. So let's go back to this question. You guys just got rickrolled, right? You guys, I hope you know what rickrolling is. If you don't know, you have to do it to your friends. It's a really old thing. It's like from, I don't know. It's probably from the year like 2006 or something. All right. Look it up on the internet. You'll find it. So here we go. So we were going to figure out all the values of theta if tan theta equals 1. And it's on this interval. So this is a big interval. This is negative 360 to positive 360. So what I recommend doing is we're going to split it up, and we're going to look at just the positive side first. Okay, Mama used to say, look at the positives first. Okay, so if we draw a little picture here, and we just write down tan theta equals 1. Well, I said this is some review from grade 11, so you guys actually would have memorized this value in grade 11. If you find the actual value of theta, you guys have to do inverse tan, and you type in your ratio. Okay, so this is one you memorized, and if you don't remember, that's okay, but I hope that you go back and review that stuff. Or you can plug it into your calculator. If you don't remember, you should get 45 degrees. Okay, if you're not getting 45, make sure your calculator is actually in degrees and not in some other measurement like radians. We will be doing radians in the future, but right now this is sort of a review question. So, where is the angle 45 degrees? Well, here it is. And actually, this is called our reference angle. So just remember, and this is review from grade 11, reference angles between the terminal arm and the x-axis. So this might not necessarily be an answer, though. We need to look back at our original given ratio and say, oh, tan theta is positive here. So we need to go find the two places on the unit circle where tan theta is positive. Just remember that tan theta is the ratio y over x. So if you start thinking about your y-axis and your x-axis, they should both be positive, or work out to be positive. So in quadrant 1, tan is positive, so it turns out that our reference angle in this case is actually a solution. Well, that's one solution. It's going to happen in one other spot. So if you start going around and thinking of each quadrant, you might remember from grade 11, well, in quadrant 3, tan is positive. Okay, so why is that? Again, it has to do with the ratio y over x. So it's really simple. If you're, just think of your y values. Okay, my y values in quadrant 3 are negative. My x values in quadrant 3 are negative. A negative divided by a negative overall is positive. Okay, so we know that tan is positive in quadrant 3. So what would the angle be in standard position? So we draw our terminal arm, okay, and we draw our reference angle of 45 degrees. Remember, the reference angle is between the terminal arm and the x-axis. When they ask us for values of theta, they are really asking for it in standard position. So in standard position, that means we're starting here, we're going all the way around, and we need to know how many degrees is it from here to here. Well, again, review from grade 11. So the answer is 225 degrees. Why is that? Let's think and look at the picture for a second. So if right here, if that's 180, if I go an extra 45 degrees, then that's 225, right? Just add them up. Okay, so those are two answers from 0 to 360. Problem is they asked us from negative 360 to 360. So I split it up because it's just easier. So now I'm going to think from 0 to negative 360. You know, it's going to bother me. I should have written that the other way around. So negative 360 to 0 degrees. Okay, and you're going to remember that we are going clockwise and doing this. So we're still thinking, where is tan theta positive? Where is it positive 1? And the answer is still going to be, well, in quadrant 1 and in quadrant 3. But we're thinking about this a little differently now because we're going on the negative side of things. Okay, so if I draw my reference angle of 45 degrees here, okay, so that doesn't change. What changes is the way that I'm stating my answer. So I'm starting here, and I need to know how many degrees is it to get that way. Okay, so this would be negative 180 degrees. So the way to think of this one is to say, hey, if I want to get here, then that's the same thing as starting at negative 180 and adding that reference angle, right? I'd be getting in the same place. So I'm going to go negative 180 plus 45 degrees. And you're going to get negative 135 degrees equals theta. So that's another possible answer. We also need to think about this in quadrant 1 over here, because that's another place where tan is positive. Okay, so again, that means I'm starting here and I'm going all the way around, and I need to know how many degrees is that. Because I'm moving clockwise, it's negative. So once again, the way to think about this is to say, hey, here's negative 360 degrees. So if I start this way and just add 45, I'd be landing in the same place. Okay, so my other value for theta, when you go negative 360 plus 45, well, that's negative 315 degrees. Okay, so you have 4 answers in this question. You got negative 350, negative 135, you got theta equals 45, and theta equals 225. You should state them at the end, all nice. Doesn't really matter the order, but I'm going to go with 45 degrees, then 225, then I'm going to go negative 135, and negative 350. Okay, it doesn't have to be in any particular order. So those are my 4 answers. What does this mean for us? So this is just some extra review for you guys. So this means that, hey, if I type in tan 45 on the calculator, make sure that you're in degrees. Okay, what do you get when you go tan 45? And I'm waiting. It's probably one person scrambling for their calculator. Demi is probably still mad about that Rickrolled video. Oh man, that was fun. So when you type in tan 45, you get 1. Okay, so that just means, hey, this is the angle that gives us the ratio 1, right? We were working backwards and they gave us the ratio, we were finding the angles. You are going to do this question a million times, and it definitely comes up on the exam. So another example, just to check your work, if you got your calculator, if you type in negative 135 on your calculator, you're going to get, I wonder, it's going to be 1. Okay, so you can check any of these, you should get 1. Okay, let's keep going here. I'm going to skip this. I could put up the answers very briefly. I will do that. So here they are. So again, you can just pause the video at this point. You can check out the answers if you want to try this one out at home. And yeah, we're going to keep going here. So last question type that we're going to look at for today is that basically I give you the angle and I ask you to determine the trig ratios. Okay, so in a question like this, it says, so for part A, for example, it says determine the exact values of the 6 trigonometric ratios for 510 degrees. There's a little bit of work that needs to happen here. Anytime this is not between 0 and 360, use your knowledge of coterminal angles to find something that is manageable. Like I said, you're going to be memorizing all these values. So if you subtract 360, then now we know it's going to be so hard. Well, we're never going to know what that is. 510 minus 360, let me think here. What is it? 210... 150 degrees, I think. Oh boy, this is oh no. Oh, I actually just meant to go to the calculator. I can't think right now. Too much Rickroll. Yeah, it's 150. Pretty tempted just to. Gotta make you understand. What is it? Where did they cut to? What is that, like the Taj Mahal? Where was that? What is? Looks wonderful. Sorry, Demi. I'm so sorry. Okay, so anyways, we got 150 degrees. Now, in grade 11, you guys memorized the exact values for 150. I don't necessarily expect you to remember that. Very, very shortly, we're going to be memorizing all of these in radians. That's coming up. And maybe someday you'll remember the grade 11 ones. So anyways, you would have memorized sine 150, like what the ratio is for that. Okay, if you type it in on your calculator, you're going to get a half, or 0.5. Okay, so this is going to be a question that we're going to be memorizing this stuff. Okay, so cos 150, again, that would have been a value that you would have memorized. You're going to memorize the exact value, so I'm going to write square root 3 over 2 today, And in the future, we're going to be doing this in radians, and this value of a half and square root 3 over 2, those are going to come back. Those are going to become very familiar to us. If I type in tan 150, you are going to get, I do believe, I do declare, square root 3 over 3, that should be negative. Okay, again, your calculator is going to spit out like a random looking number. This is the exact value, and you can confirm that. And I do believe I missed the negative right here. Just kind of going off memory a bit here. So there's those ones. Okay, if you're going to find, you know, the reciprocal ones, so sine is cosecant. Okay, and we know that the value is 150. Okay, so it should follow that it's just going to be the reciprocal. No thanks. Sorry. I'm doing so much work at once here. So cosecant 150, well, that's going to be 2. Okay, just the reciprocal of a half. Secant 150, well, that's going to be the reciprocal of this. So 2 over square root 3, and it's negative. And then tangent is cotangent. That's the reciprocal. So you're going to get negative 3 over square root 3. Okay, so there's part A. Part B, determine the approximate values of 6. Who cares? Honestly, it's just another question. It's a calculator question because this is not an exact value. So let's go down here where it says B, you're going to use your calculator and enter the negative angles and find the ratios using the inverse feature. So because you're using your calculator for this one, and it could very well happen on the calculator part of the exam, you get a question like this. We don't need to bother finding coterminal angles because I can already tell it's not an exact value. So just as an example, like you would literally be going to your calculator and typing in, you know, you're looking for this. Right, so if you pop that in, you know, they've given us the angle, we want to know the ratio. So if you pop that into your calculator, I got, and remember the exam is always 3 decimals unless otherwise stated, so we're going to round to that, so negative 0.829. You actually can find cosecant by going 1 over sine, right, so going 1 over sine. Some of your calculators might have a cosecant button, so you could go ahead and use that button, or you could just type in that. If you do that, and you should try it because you never know, you might have to do it, that's what you should get, negative 1.206. So I'm not going to write them all out. I'm going to randomly pick one other one. So if you type in cos negative 416, you get 0.559. And just for giggles, secant. I'm going to slowly do them all after saying I wasn't going to do any more. For that one, though, 1.788. Okay. So, beautiful, beautiful, beautiful math. That is basically as far as I want to go in the notes. There's a bit extra, but you know, I'm not here today. Basically, the gist of this is I'm showing you the unit circle. Unit circle is basically where the radius is 1. You know, this is leading into, you know, like what's radian. So we're gonna be covering this, you know, in the future, like tomorrow or whatever. So you can do the notes, or sorry, the exercises for 6.1. Super important in this unit, I swear. I know I said that trig was the hardest unit, but I swear this unit is really dense too. It's pretty hard. So do the exercises. All right. Don't get rickrolled. Alright guys, see you next time.